Hi, I am Faisal and in this video I will explain aspect in GIS. So let's get started. Let's define aspect. As per GIS Fundamentals book by Paul Bolstad, aspect is defined as the steepest downhill direction at a point. So the aspect at a point is the steepest downhill direction. Aspect is measured in azimuth angle. It is in degrees, measured from north in clockwise direction from 0 to 360 degrees. Flat areas have no aspect. Now let's define aspect from ArcGIS. Before that, I would like to comment on steepest downhill direction. So this steepest downhill direction, this represents the slope. So aspect is in fact the steepest downhill represent the slope. So aspect is what? Aspect is the direction of slope. Now let's define aspect from ArcGIS. So we have another definition of aspect. Aspect identifies the downslope direction of maximum rate of change in value from each cell to its neighbors. So this is a long definition. Aspect identifies the downslope direction of the maximum rate of change in value from each cell to its neighbors. So let's ponder upon this definition. It identifies a direction, and this direction is downslope. Okay, so aspect is all about direction of maximum rate of change in value. So it is the direction of rate of change in value from cell to its neighbors. So this part, rate of change in value from cell to its neighbors, this represents the slope. So aspect identifies downslope direction. So basically aspect is the direction of slope. So you can tell that it can be thought of as the slope direction. Why we call it as thought of as a slope direction? Because this aspect is a mathematical definition. These definitions are actually reflecting the mathematics which are used to calculate the aspect. Now to understand more, let's come to the third definition. This definition is now from Spatial Analysis book by D. Smith. So let's define it. Aspect is defined as the directional component of the gradient vector and is the direction of maximum gradient of the surface at a given point. So it is actually a directional component of gradient vector. What is gradient vector? Gradient mean tangent vector. Okay, so it is the directional part of a tangent vector of a tangent. Okay, now let's explain it more. It is the direction of maximum gradient, mean maximum slope of the surface at a given point. So this again reflect slope. So it is the direction of the slope or the directional component of the slope. So this is aspect. So in short, we can think of aspect as the direction of slope. In ArcGIS for flat surfaces, the aspect will be -1. Okay. Now let's talk about application of aspect, why we need aspect. So aspect is used in finding flow of water, finding direction of water, it helps to estimate amount of sunlight a site may receive. It determine the portion of landscape visible from any viewpoint. Aspect also represents the best slope for skiing. The best slope for skiing are north facing slopes. It also identifies the solar illumination in a region, which I have already said. Aspect also identify the location where snow is likely to melt first, and that will help to identify residential location likely to be hit by runoff first. So runoff of water, region where snow will melt, and that region would likely to be southern slopes, southerly slopes. Aspect also identify flatlands, and flatlands are useful for emergency landing of planes. So these are application of aspect. Let's talk about formula. Or algorithm. So different books have presented different algorithm for aspect. For example, in JS fundamentals, aspect is defined as alpha, and this alpha is equal to 180 minus arc tangent. Arc tangent mean inverse of tangent of slope in y direction divided by slope in x direction plus 90 of slope in x direction divided by absolute of slope in x direction. So this is one of the formula for aspect. Let's have another formula from principles of a geographical information system. So this formula is devised by Zevan Burgen and Thorn. So aspect is, I'll use same alpha, arc tangent of minus h divided by minus g. This formula is listed under method by Zevan, Burgen, and Thorn. Where h is equal to z2 minus z8 whole divided by 2d and g is equal to z4 plus z6 whole divided by 2d, where Z values are following. Z values are there's some mistake here. Let me rewrite them again. This one is Z5, Z1, Z2, Z3, Z4, Z5, Z6, Z7, Z8, Z9, and this is your D, which is cell size. So this is another formula for calculating slope. According to ArcGIS, the slope is following. The aspect is following. An aspect is based on the slope. So aspect is, I'll again use alpha, A10 of A10 2 of slope in y direction and the second argument is minus slope in x direction. But there are further conditions, and this A10 should be multiplied with 180 divided by pi, which is 57.29578 to convert the resulting answer from radian into degrees. So there are some conditions for aspect that the final answer of aspect will be as per following. It will be either one of the following. It can be 90 minus the aspect value if aspect value is negative, or it will be (360) minus aspect value plus 90 if it is greater than 90, or it can be 90 minus the aspect value for otherwise. So if the aspect value is negative, it will be 90 minus aspect. If it is greater than 90, then it will be 360 minus aspect plus 90. And when we have otherwise condition, means not fulfilling the first two, then it will again be 90 minus aspect. Here one thing to note is that we have 8 and 2, and this 8 and 2 can be you can find it in programming languages, in the math library of programming languages, in spreadsheets like Libri, Calc, and Excel or Google Sheets, but you may not find this in scientific calculator. So what is 8 and 2? So for that, let's open Google and let's search for 8 and 2. So, and there is no space. So let's go for Wikipedia to understand about it. So basically 8 and 2 is a function. Okay, it is accepting two arguments. The first will be y, the second will be x, and how we can define it, it is actually the angle. The result of this is angle in Euclidean plane. Okay, so in short, 8 and 2 is basically a tangent but with certain conditions, and those conditions are defined here. Basically it is arc tangent, tangent inverse, but with certain conditions. So basically alpha is 8 and 2. Okay, and this 8 and 2 goes through certain conditions. If the value of aspect is negative or greater than 90 or otherwise. So this is the calculation of aspect. It will calculate angle for you. Then what is need of this? We have already covered the conditions which you can see here. So what need of either this one or this one? So what's need of these conditions? This condition helps to convert the angle, resulting angle, into compass direction. So that's it. This is a theory about aspect. One thing more, that before we end, that in ArcGIS, aspect is calculated for two coordinate system. One is planar, the other is geodesic. The planar calculation has been shown here in, so let me write about this calculation method of aspect. One is planar, which we have already discussed. The other is geodesic. In planar we use Cartesian coordinates. In geodesic we use latitude, longitude, and altitude, height. So alpha and the lambda is actually longitude, phi is latitude, and h is the height of surface from ellipsoidal datum. Among them, the more accurate is, as per ArcGIS, is geodesic. Okay, the formula is same as I have listed above here, but in the only difference is coming from the calculation of slope. So this change is appeared in a new ArcGIS, in which they have included calculating aspect directly from geodesic, in which basically you calculate slope from geodesic. And in planar the formula for aspect is same as we have discussed above, but the slope is changed. Okay, but in short, basic definition and formula are listed here. Okay, so that's it. I hope you guys learn something, and you guys learn the basic formulation, the concept behind, and what's new feature in ArcGIS. So thank you.